Arrange the following in order of increasing radius. But we have the formula to follow.
Z effective equals nuclear charge minus shielding.
Nuclear charge is Z minus the number of shielding electrons. Right. In the multiple choice paper, you won't get the data booklet, but you will get a periodic table. So you get a periodic table to work with this, but you don't get a data booklet because the data booklet does have on page 9 all the atomic and ionic radii of the elements. So then you'd have the ionic radii here, so you can just look it up. But without this table, and with only a table that's going to show you like the atomic number or the number of protons, if you have a table that's showing you just the atomic number, you'll look that up. That's the kind of periodic table that you will get. The atomic number of potassium is 19, chlorine is 17. So for each of these, you would work out what is the effective nuclear charge. In the case of potassium, it loses 1 electron. It's going to be 19. So therefore, how many shielding electrons do you have?
18.
No, because a valence electron is lost. It has lost its valence electron. So then this now becomes its valence shell. So then it has 10 shielding electrons. And then it becomes positive 9. Let's try another one. Let's try sulfur. Tell me what's happening with sulfur. It gains 2 electrons, yes, so then. But where is it to begin with? It's this. And then it becomes that. So again, you notice something? It's probably going to be like that for all of them. They're all going to have this common shielding factor. Then this though has how many protons? 16 minus 10 + So where are you going to put potassium in relation to sulfur? Which has the bigger radius? Why? Sulfur has the bigger radius, and why?
Because it has the bigger charge pulling it.
So sulfur has to be down there somewhere. Potassium has to be somewhere down on this side. Right? Because the net positive charge, or this effective positive charge that you have here, is 9, and the effective positive charge here is 6. Notice they both have the same number of valence electrons. They both have the same number of electrons shielding. So therefore, the only thing that's making the difference, I think, in all of these, what you will see, it's in all of these, is the number of protons. So you already get the trend. And calcium actually has the most protons, doesn't it? So that's going to be the one that's going to come in first. But you can plug this formula in for all of them, and you can see they're all going to have the common factor here of 10.
Because they're the same.
And then this is just based on how much positive charge there is. So then it's calcium, potassium, sulfur is here, and then what else? What's the rest of the order?
So chlorine is after potassium.
Chlorine should actually come before because it has more protons.
The last one's phosphorus.
And the last one is phosphorus. Okay? And this is not just atomic radius, it's ionic radius. But once you understand how we look at the trend for atomic radius, you just apply the same formula